Jai Hind everyone. My name is Mamta Pant and I'm working as an assistant professor in IT department of Ajay Kumar Garg Engineering College, Ghaziabad. Today we are going to discuss ER model that we used in DBMS. So let's start it. So these are the headings which we will discuss in today's video lecture. First of all, we will discuss about the ER model concept. What is the ER model? What the keywords we used in the ER model? Next, the type of attribute. And after that, the notation we will use in the ER diagram. After that, the mapping cardinalities. And after that, extended ER model. And after, at the very end, how we reduce an ER diagram into the table we will discuss in this video lecture. So let's get started. First of all, we need to discuss about the ER model concept. What is the ER model? So the very basic thing we need to know, what is the full form of ER? That is Entity Relationship Model. So ER model stands for Entity Relationship Model, and it is a high level data model. This model is used to define the data elements and the relationship for a specified system. So basically, whenever we want to store the data or any information in the form of database, so first of all, we need to convert it into a design in our brain, in our thoughts. So this design, when comes into the paper, is known, we translate it into the form of entity relationship model or data elements and the relationship for that specified design in our mind. Next, it develops a conceptual design. What is the meaning of that conceptual design? Conceptual design means the entities we are using in our ER diagram, how they relate with, how they will have the relationship with other entities or attributes, is known as the conceptual design for the database. It also develops a very simple and easy to design view of the data. View, the result seen by the user, is known as the view. Next, in ER modeling, database structure is portrayed as diagram. Okay. The design that we think or we are planning for making in the form of database is portrayed into the form of the diagram, and this diagram in ER model is known as Entity Relationship Diagram or ER diagram. Next, we need to understand what is the entity. An entity is a thing or an object in the real world. Anything which can be recorded is known as the entity. So these things are only those things which we can record or the data about which we can collect. Only those things are considered as an entities about which we can collect the data or we may record the data. Next, the entity may be a tangible object. Tangible means like a student, a place, and an entity may be a non-tangible object such as an event, a job title, or a customer account is the non-tangible entities. Let's have an example. If we say a customer buys a goods, a customer buys a good. In this statement, customer and goods both represent an entity because they are the thing, okay, or object. So customer is one entity and goods is another entity. Now come to the entity set. It is a set of entities of the same type that share the same properties. Basically, the collection of entities that share the same property is known as the entity set. For example, the set of all persons who are customer at a given bank can be defined as an entity set customer. Now, entity may be of two types. One is a strong entity, second one is weak entity. Now, what is a strong entity? An entity that does have a primary key. What is the meaning of primary key? It means that an entity have a single, at least one property, so that we can define the entire entity with the help of these properties known as the primary key. So if an entity has such kind of property or characteristics in itself, so that with the help of this special characteristics we can define the entire entity, is known as the primary key, and that entity is known as the strong entity. And the second one is the weak entity. If an entity does not possess any attribute, any properties with the help of which we can define the entire entity, that entity is known as the weak entity, or in the form of primary key we can say which does not possess sufficient attribute to form a primary key. That entity is known as the primary entity. Next are the attributes. The properties, the characteristics that an entity may have is known as the attributes. In database, entities are represented with the help of table and attributes are represented by columns. For example, a customer entity may have customer code, customer name, customer address. So all these three things are the properties of customers. So that's why the customer entity may have these attributes: code, name and address. Next is the types of attribute. How many types of attributes we can use having in AR model? Single valued and multi-valued attribute. Second is your derived attribute, and third one is your simple and composite attributes. Now let's discuss one by one. Simple and composite attribute. What is the meaning of composite? Composite means combination of two or more. Anything which is a combination of two or more is known as the composite. So composite attributes means the attributes having one or more attributes in itself, or combination of one or more attribute is known as the composite attributes. For example, let's have an example of address of a customer. So address of a customer is an attribute because it is a property of a customer. So address is an attribute. So in many places you have seen, when you filling the form, you see address will be break down into this form, like gully number, state, district, city, pin code, such things. So this address attribute is divided into these following further attributes: valley number, state, district, nearby location, state, pin code, etc. So this address is now known as a composite attribute because it is a combination of more than one attribute. But in another case, simple attribute. In simple attribute are those attributes that cannot be divided into subpart. For example, age. You cannot further divide the age. Next is your single valued and multi-valued attribute. So the attributes having a single value is known as single valued attribute. For example, your Aadhaar number. Your Aadhaar number may be single value, so it is known as single valued attribute. Next is your multi-valued attributes are those attributes which are having multiple values. For example, mobile number. A person may have more than one mobile number, may have more than one mobile phone. So mobile numbers or mobile is known as the multi-valued attribute. Next is your derived attribute. As the name suggests, it is driven by the another attribute. So these can be derived from other attributes. For example, you have date of birth. You have date of birth and attribute in your table. So with the help of date of birth, you can calculate the age of a person. So age is here as a derived attribute. Next, some terminologies are there which we use in the ER diagram, ER model. First is your domain. Domain is of an attribute is the collection of all possible values an attribute can have is known as domains. Next is your field and column. A column represents one related part of a table, is the smallest logical structure of the storage in the database, or it holds one piece of information. For example, I have an entity customer. I have an entity customer, and customer can have attribute name, address. Let's suppose we have only two attributes here, name and address. So this name is a single piece of information about the customer. So this is known as one field or one column of table customer. Next is record or row. A record is a collection of related multiple fields that can be treated as a unit. In database terminology, each row is known as record. For example, this is the table in our database. So this is known as field and column, and this is known as row or record. Next is table. Table is a named collection of logically related multiple records. When we combine multiple records, 1 record, 2 record, 3 records, 4 records. So this combinedly is known as table. So in this example, you may see this is a complete table. This is known as the table or entity set, and these are known as the field or columns, and ID, name, section, date of birth, gender are known as the attributes or fields, and these are known as the attribute value, and ABC is the domain of this particular table. Next, we use some notations in the ER diagram as follow. This is used to represent, rectangle is used to represent the entity, and if we want to represent the attribute properties of that entity, then we will use oval. After that, the relationship is represented by the diamond. Relationship between two entities is represented by diamond, and the link between entities and attribute is represented by this single line, and multi-valued attribute is represented by double oval, and dotted oval is represented the derived attributes. After that, these links represent the total participation of the entity in the relationship. This represent, double rectangle represent the weak entity, and same double diamond is represent the weak relationship. And if we have the composite attribute, which is the combination of one or more attributes, this is represented by like this. And a key attribute like primary key, candidate key, special attribute is represented by oval and underline. So these notations are very useful while we draw the ER diagram. Next, this is the example of ER diagram. Suppose I have an entity student. So student is represented by, entity is represented by rectangle. So we will place a student entity as in rectangle. Now, ID, name, address and age, these are the properties of a student. So they will work as an attribute for the entity student. Name, address, age and ID. We can further divide it into it. ID, student ID will be the primary key for the entity student. So I can represent it as this is represent as primary key. Now age is a derived attribute. So we can also represent age is like this derived attribute. Address is a composite attribute. So we can further subdivide it into state, district, city. So this will become the multi-valued attribute. Name can also be multi-valued composite attribute like first name, middle name and last name. So like this we can draw the ER diagram. Next example. Here we have two entities. One is a student and other one is the college. So what is the relationship between student and college? Student study in the college. So this relationship is represented by diamond as we learned into the notation of ER diagram, and these are the link represent that a student study in the college. These are the links. Okay. Now the student, how many attributes can have? Multiple attributes. Here we have taken student ID. This will be the primary key, student name and student address. And college can have student college ID and college name. Next topic comes mapping cardinalities or cardinalities ratio. What is that ratio? Basically, it is a number. Okay. Basically, it is a number. Now, what kind of number it is? It is a number so that an entity, if we have a relationship between two entities, A and B, we have two entities and we have some relation between them. So how many numbers we can associate with A? How many numbers we can associate with A is known as, or how many numbers is associated with A or B is known as mapping cardinality or cardinalities ratio. So here we have the definition. Mapping cardinalities express the number of entities to which another entity can be associated via a relationship. We have four types of mapping cardinalities: one to one, one to many to one and many to many. First of all, we have look into the one to one relationship. An entity in A, this is entity A, is associated with at most one entity in B. an entity in A associated with at most maximum one entity with B, and entity in B is associated with at most one entity in A. Here is the example. Let's have an example so that it will clearly understand what is the one-to-one relationship. Here we have customer, here we have driving license. One customer may have only a single driving license. So entity in A is associated only a single entity in B. One customer can have only a single driving license. Now, a driving license, single driving license only associated only a single customer. One driving license cannot be distributed to two or more customers. Only a single customer it will be distributed. So here we have one-to-one relationship. One customer have one driving license is associated with only one customer. So this is known as one-to-one relationship. This is graphical representation of one-to-one relationship. Next is your one-to-many relationship. An entity in A is associated with any zero or more entity in B, and an entity in B is associated with at most one entity in A. Here we have an example, employees and team. You can clearly see that an employee can manage more than one team. An employee E1 is managing team 1 and team 2. This is possible. An employee can manage more than one team, but one team is managed by only a single employee. Okay, so this is called one-to-many. An employee can handle more than one team, so this is many, and one team is only associated by one employee, managed by only one employee. This is known as one-to-many relationship. Next, many-to-one relationship. Here we have example of credit card and customer. Here you can see that a customer can have more than one credit card, 2, 3, 0 or many. But a credit card belongs to only a single customer. So this is known as many-to-one relationship. Next is your many-to-many relationship. This is the between customer and product. A customer can buy more than one product, and a product can be purchased by more than one customer. So at the both hand, this is the many-to-many relationship. A is be associated with many numbers of entities in B, and number of entities in B can be associated with any number of relationship with A. Next, extended ER model. What is the extended ER model? Till now we have discussed about the ER model, ER diagram, entity relationship model. Now we will discuss a further extended form of ER model, that is known as EER model. EER model, that is extended entity relationship model. Okay, this is also a high level data model. It is only data model, not a database, not a table. It is just a data model. Okay, enhanced entity relationship diagram are high level data models that represent requirements and complexity of the complex database. So in extended ER diagram, basically we are coming with the 4 new concepts. These are these 4 new concepts which we do not follow in the normal simple ER model. We will use these 4 topics for definitions in only extended ER model. These are subclasses and superclasses, specialization and generalization, category or union type. Next is your aggregation. First of all, we will discuss about the subclass and superclass. Superclass is an entity that can be divided into further subtype. Subclasses are the group of entities with the some unique attributes, and subclass inherits the properties of attribute from the superclass. For example, consider shape is an entity, but shape can further be subdivided into triangle, square and circle. So this is the concept of subclass and superclass, where superclass is subdivided into the subclasses based on some properties which are common into the class. So all the triangle possesses some common attributes, all the square possesses some common attributes, and same with the circle. So this is the concept of subclass and superclass. Next is your generalization. Generalization is the bottom-up approach in which 2 or more lower level combine to form a higher level entity. Here we create a higher level of entity with the combination of lower level of entity. In generalization, an entity of a higher level can also combine with the entity of lower level to form further higher level of entities. Generalization is more like the subclass or superclass concept we have studied in the previous slides, but the only difference between generalization and subclass and superclass concept is that generalization is used bottom-up approach, while subclass and superclass use top-down approach. In generalization, entities are combined to form more generalized entity. That is, subclasses are combined to make a superclass. For example, here faculty and student. We have faculty and student, two entities, but these two entities possess the attribute or property or characteristics of the person. Faculty also have the attributes or properties of person, and students also have the property of person. So the person property is common in both of the entities. So we will combine them together to make it as a person. So we will combine them to make it as a person. This is called generalization. This is bottom-up approach. Next is your specialization. Specialization is just opposite to the generalization. In generalization, we will follow the bottom-up approach. In specialization, we use top-down approach. It is opposite to the generalization. In specialization, one higher level of entities can be broken down into two or more lower level of entities. Specialization is used to identify the subset of an entity that they share same distinguished characteristics. Normally, the superclass is defined first. First of all, we need to define the superclass, and then we need to discuss the subclasses, and its related attributes are defined next. Relationship sets are then added. Okay, let's have an example of a specialization. Here, employee. I am doing recruiting in my company, for example. First of all, I need to recruit them as an employee. Okay, he is a part of the company, so he or she will become the employee. But when he will join the company, then I will decide I should send him the testing department or development or coder department. So an employee is either tester or employee. I further subdivided into the different categories. So this is known as specialization. Specialization is top-down approach. Generalization is bottom-up approach. Opposite to each other. Next is your category or union. When we combine when we combine two or more entities into a single entity, then it is known as the category or union. The relationship of one super or subclass with more than one superclass. Here, not a concept of super or sub, definitely should not be super or sub. They all may be superclasses, or they all may be subclasses. So here we can see clearly in the example, an owner may be is of vehicle or maybe is of house. Here all three are the superclasses, different superclasses, and we are getting union here to combine them to get their data combinedly. So this is the concept of category or union. Next, what is the aggregation? In aggregation, the relationship between two entities treated as a single entity. In aggregation, relationship with its corresponding entities is aggregated into a higher level of entity. Let's suppose we have an example. A visitor is coming to the college to visit the college. So the visitor may only not to visit the college. He must also get the information from the college about the courses, about the activities the college have. So this is the example. Here we have the center, or you may say college offers courses. So this is a relationship. College, between college and courses. Now a visitor come to visit the college. So the visitor may visit also college and also get the information about the courses. So instead of having two relationships with visitor and college, visitor and courses, we have only single relationship with visitor, and this whole relationship work as a single entity for visitor to minimize the complexity. So visitor inquires about all these relationships. This concept is known as the aggregation. Next, topic come how to reduce this ER diagram into the table. First of all, we have thinking about the database, the information we need to store in our database, and after that we will create an ER diagram, conceptual design of that thinking, of that thought. And next, after creating a ER diagram, we need to recompose this ER diagram into a table. So how we can do that? There are some rules to do that. The database can be represented using the notation. The notation can be reduced to a collection of tables. So here we have some rules to do that. The very first rule, entity types become a table. All the entities may become the table. All single valued attributes become the column for a table. Third one is a key attribute for entity type represented by the primary key. Next, the multi-valued attribute is represented by separate table. All the multi-valued attributes that we have more than one value. That attribute is known as multi-valued attribute and represented by a separate table. Composite attribute is represented by component. Next is your derived attribute are not considered in the table. So we will have an example. This is the ER diagram and we need to convert this ER diagram into the tables. How we will do that? Okay. First rule. What was the first rule? Entity types become a table. So first of all, we need to see how many tables we can have in this relationship. One table is student. This is one entity. Second entity is course. So second table is course. Third entity is lecturer. So third table will be of lecturer. And fourth is of subject. So fourth table will be of subject. So we have four tables: student, courses, lecturer and subject. We have four tables till now. Now, what was the next rule? All single valued attributes become the column for the table. Single value attributes are course ID, student name, student ID, age and date of birth. Okay, but what the next say? Primary key attribute of entity type represented by primary key. So what is the key attribute here? Key attribute here is the student. So student ID will become the primary key. What is the next? The multi-valued attribute is represented by a separate table and composite attributes are represented by component and derived attribute are not considered in that table. Okay. Here derived attribute is your age. So this will not be considered. This will not be considered into the table. Now multi-valued attribute is what is multi-valued attribute here? Address is your multi-valued attribute. So we will not write it as address attribute. The address is represented by its component like door, street, city, state, pin. Next, what was the next? All the multi-valued attribute. For example, a student can have more than one hobby. So multi-valued attribute is represented by another table. So we have another table for hobbies. Now, this is the final answer of this is final reduction into the table of this ER diagram. We have student, lecturer, subject, course and student hobby. Here we have student ID and this is the primary key. Student name, date of birth. Okay. Now door, street, city, pin and course ID. Okay. We have another table of hobbies, but we need to relate this student hobby with the student because student hobby is the attribute of student table. So we will connect this with the student ID. Now next is lecturer. Here primary key is lecturer ID. Next is lecturer name and course ID. Next table will be of subject ID, subject name and lecture ID. This will be the primary key, subject ID. Next will be the course ID will be the primary key and this will be the attribute. So this is the relationship between tables and this is the purely reduction of an ER diagram into the table. Thank you for today. We will meet soon with the next video. Thank you so much.